Hi, everyone. This is Patricia again, and I would like for you to pay attention as we go along. If any question comes to mind, kindly put the question in the chat. Then I would look at them at the end of the training. This training is going to last an hour, all right? And during the Q&A session, we'll go over the questions. If anyone has put any question in the chat, we have some of your buddies on the call as well, and I'm sure they can pick up some of the questions and answer while the training is on. But let's pay attention and please note your questions. Yeah, thank you. So, what are we doing today? Today we are going to be talking about the basics of networking, because it's important for us to understand what networking is and what network security means. What is a network, the types of uh, network devices, network protocols, network topologies. These are things, concepts that you're going to be seeing a lot in this journey. And why is network security important? And just before I go into that, just to bring us back to uh, what we talked about last week, cybersecurity is a broad field. It encompasses various elements, and these elements the objective of these elements are aimed at protecting computer systems, protecting networks, protecting data, or protecting information from unauthorized access, um, protecting them from attacks, protecting them from damages or theft. Yes, data can be stolen and it is a crime, and it can be a big issue for any organization. And network security is a key element of cybersecurity. Networking on its own is a key element. And it's one of the foundational things that you can't ignore, okay, because you don't want to be in a meeting where they're having some important discussion, slightly technical, not too deep, and you don't understand what they're talking about. So this is not a networking class. However, we want to touch on the basics of networking so that these things would not be strange to you when you go out there. And as a matter of fact, you would get on some interviews for a SOC analyst role, which is why we're having to deal with this now. And you are being asked basic questions around networking, and it will be a shame not to be able to. It will be a shame not to be able to respond to that. Okay, so please pay attention to that. So, what is networking? Is a process that connects everyone. It connects myself to you. It connects yourself to myself. It connects everything, devices, systems, and network on the internet together. Everything that happens on the internet happens within a network, around the network, outside the network. You know, there's just a connection. And what is a network? Is a collection of two or more computers, servers, mainframes, network devices, or other devices connected to one another to share data, to share resources and services. So any device is connected. I mean, like in our homes right now, we are able to um, use our phone and use an app on our phone and also get on our laptop or on our desktop, use the same app. So some sort of connection is happening there. There are different devices. However, what brings them together is a network. And these devices in our home are within the same network. All right. And we have network security. So what network security does is that it is an element of cybersecurity, and it ensures that all these components, hardwares, softwares, protocols, encryption, they are configured according to standards and procedures that establish the security of data information. So there are standards that are acceptable, that are industry expectation, that that ensures that in order to secure data, information, or resources, the configuration must be what the standard states. And there are different standards. We will learn more about that later. Now, when we talk about network, there are different types of networks. So I'm sure we're all familiar with the LAN, the local area network. So this is the network that spans a small geographical area, such as a single building. So if you compare a LAN to uh, compare it to like a small neighborhood where everybody knows each other, a single building or a group of buildings. Okay, myself in my house, you know, we are on a LAN network. That's a single building. Group of buildings, well, my neighbor as well, if you get what I mean. Then we have the wide area network. This is a network that spans a large geographical area. So this is where we are looking at multiple neighborhoods. So for example, if you live in an estate, uh, you're all, let's say you're all probably in a specific, you belong to a specific local area network, because it's just a group of buildings in an estate. But um, the moment we are having multiple neighborhood, multiple estates, so it means that that network is spanning across a large geographical area. So the wide area network, the one connects the local area network and other types of network. So over long distances, so they could be using leased lines, as mentioned here, or fiber optics or satellite links. So that is the one. Then we have the wireless local area network. So it's kind of similar to a LAN, but because it uses a wireless technology to connect devices within a limited area. So it's usually managed by a single organization or a single um, entity. These three are popular. And if you look at the virtual private network, there's a long list of this network. I'm going to talk about them as well. So this VPN, the VPN is a virtual private network, and you're going to hear a lot about VPN when we start to get hands-on on our SIM tool. So the VPN utilizes public telecommunications and those kind of infrastructure that are encrypted. The connection that are encrypted over a public network, and they can be owned and managed by an organization or provided as a service by VPN service providers. I know in some places, like sometimes I want to speak with somebody in Qatar. They can't just go directly using their using their wireless, using their phone. They need to connect to a VPN. So the VPN is like a middle man connecting that needs to be in place before they can connect and speak with other people. It's some sort of security measure that has been put in place uh, in that regard. Then we have um, then we have another example of such is the, let's say, of the virtual private network, uh, like a remote access for those people that work from home. Okay, you use the VPN. Your company provides you the VPN so that you can securely connect to your company's internal network from outside location. All right, and we have there's there's one another type of network is called MAN, Metropolitan Area Network. So this covers a large geographical area than land, but it's smaller than a wide area network. It's typically a city or a metropolitan area. For example, a network that provides internet access across a city. That would be an example. And usually the technology used are fiber optics cables or wireless connections of some sort of combination of technologies. Then there's another one. I've read about storage area network. So this particular one, it's not on in here, but I would suggest that you do a bit of research to check for additional types of network. I've only listed this four. So the network that connects servers to storage in a data center, okay, because that kind of network, in a data center, you need a network that's got high speed data access and storage management. Okay, why is network security important? Why is network security important? Yes, there's no way you want to protect something that you don't understand how it operates. You need to understand how it operates, then you would know how to protect it. And don't forget that the network, the reason why we want to protect the network is because there are some bad actors out there. They want to disrupt the flow of the business from some do it for fun, some uh, some are instigated by um, governments, uh, government having the government of one country having to attack the other, political reasons, and some do it for money, and some because they are disgruntled. Yeah, an insider can exploit the network of the organization where they work. So if your boss is not paying you um, the salary that you expect, and you feel that you are working too hard and getting less pay, people can get disgruntled. They feel they're not listened to, and you put that kind of person in charge of your organization's security. You see why it's good, why this profession is good. You get paid well, so you are not disgruntled on the job. But, some people can be greedy. Anyway, that's on the lighter mode. However, why is network security important? It's important because we want to understand how networks operate. We want to understand how networks can be exploited. So this is where we, as security analysts, we're wearing the hat of um, of a detective. We want to find out how do these attackers operate, and there are some tools we can use to see some ways where they how they operate, some frameworks, then how to secure them. You can't give what you don't have. You need to understand how they operate to know how to secure them. So it's like there's headache, you can take paracetamol. It's as simple as that. Sometimes the stomach ache, your doctor says take paracetamol. And some people wonder why are they prescribing paracetamol? Because they think paracetamol is just for headaches. No, it's a pain reliever. Okay. So you need to understand how it works. What is the problem? How do I deal with it? All these things I'm saying are from a place of experience of interview questions. And you being able to explain also will help you in the interviews. Even you trying to give some relatable examples, you know, it does help a lot. Now, let's talk about network devices. So, in a network, you have a hub, you have a switch, you have a router. I mentioned all of this. I listed this last week, but I didn't go deep into it. So, if you can, a hub connects multiple devices in a network. So, imagine you uh, as a hub. Maybe you have that kind of personality. You are the one that can bring people together. Oh, they hear your name. Oh, this person, I reckon this person can bring. So that's what the hub does. It connects multiple devices in a network. So these devices are wired devices and they are not as smart as switches and routers. Okay. Then we have the switch. And there's something I need you to pay attention to here. These devices are more intelligent than the other. So, for example, they usually say the switch is an intelligent hub. So there's a hub, there's a switch. The switch is more intelligent than the hub. So a switch is, they are also wired devices. However, they know the addresses of the devices connected to them and they direct traffic to that port. So the hub just connects the devices. They they don't know the addresses. That's one of the differences. They don't know the addresses of the switch, but the switch knows the addresses and they connect them and direct traffic to that port. Now, if you can imagine a switch to be a traffic signal, intersections, controlling intersections. No, it knows, okay, at this point, I will direct the traffic to this port. Okay, because there is a lot of traffic coming in and out. So that's what the switch does. The switch directs all the or it directs traffic to that specific port. And the hub is just like a loudspeaker, just broadcasting the message to everyone. Okay, this is the message everyone, all the multiple devices on the network have. All right. Now we have the router. Now the router determines the most efficient direction of the traffic, and say the router is more intelligent yeah, than the switch and the hub. I think the router knows where exactly it knows where exactly it needs to direct the traffic, the most efficient direction. Okay, this specific traffic, I'm directing it across the specific network because They are across the specific direction because this is the most efficient. I'm not just directing it because I know the address. Okay, they are smarter than hubs and switches. They can be wired or wireless. All right. Then we have the firewalls like firewalls, you know. So and they I always remind remember the purpose of a firewall because of the F word, fire, filter. They filter they filter the traffic in the network. If you hear if you see hear the word firewalls in the in this context, remember the F word that these are is a network device that filters the traffic in the network. So they are used to manage and control traffic in the network. They protect the network. They call it a network filtering device. And they don't just do the filtering by that, like on your laptop. You if you go in through the control panel, during one of our workshops, we'll go over some of these things so that you can actually see. So you can set up specific rules uh, for on your firewall so that they can filter based on this specific set of rules or access control list. Then we have the server. A server is a computer or a software program. The server provides services and resources or data to other devices. They are like the every service or resource that other devices need to connect to in a network. The server is designed to handle such requests. Okay, and they they get the request and respond to this request accordingly. Usually, servers run on some specialized operating systems, and they have to be at the optimal level because you need if imagine I am a server, I'm served, I have to be at as in like at 101% optimum performance because if something goes wrong with me, then the other uh the other computer or devices looking to obtain some information or resources or some connection, making some requests for me, they can't get it. I'm sure you've all seen this all this server error or when you're attempting to connect to a website and it's saying server error, error 500, all those things. So the servers provide services to other computers or devices on the network. Then we have the endpoint. So an endpoint refers to a device. Please note all of these are network devices. So for example, you are in an interview, they're asking you what network devices are you familiar with. So all of these are network devices. The endpoint refers to a device that serves as a um, point of access, like entry point to a network. And that is if and these endpoints can be computers, it can be laptops, it can be IoT devices, or any other device that is connected to the network. One thing that is really important to know, because sometimes you go on the job boards, you would see some job roles they're saying somebody that's got desirable endpoint uh, security knowledge, or experience. So if you understand what an endpoint is, and it is important to know that securing this endpoint protects devices from cybersecurity threats. threats like malware, ransomware, even data breaches, any form of unauthorized access. It is really crucial because, if you endpoint, don't forget it starts with an E, endpoint, entry point. So the endpoints are most often the entry point for cyber attacks. Please don't forget that. If you don't remember anything tonight, please remember that. They are most often the entry points for cyber attacks, and securing them is really essential for protecting the overall network and its resources. So if there's a crack in the wall, if there's a vulnerability in the endpoint, it can destroy a lot of things. In fact, the overall network is put at risk and all the resources within that network. Then we have the Ethernet, not internet, Ethernet. So it's widely used for wired local area networks and the metropolitan area networks. So the Ethernet, it defines the physical and data link layers of the OSI model for network communication. You're going to, as on the next, I think in the next two slides, you're going to see the OSI model. So please just note that the Ethernet defines the physical and data link layers of the OSI model for network communication. So I'm going to go on to the next slide and talk about the network protocols. So I've picked all of these network elements because it's really important that as we are learning and them, the understanding is established with us, and we are able to explain them even in our own words. So network protocols, they are like, just before I go into this, they are like the languages that the computers use to communicate with each other. So there's an established set of rules that determine how data is transmitted between different devices in the same network. For example, if I'm having a simple dialogue between myself and another person where I represent a computer and I'm the one sending the data, and the other person represents another computer and he or she is the one receiving the data. They receiving the data. So in a way, there's a protocol, there's an agreed communication rule between us. So that is the protocol. So greeting is responding, and if my greeting is in English, you understand, is responding, he or she's responding. I'm asking questions or I'm giving responses. So that kind of explains how the network protocol works. Because if two people are from different countries and they're trying to communicate, they need to speak a common language so that they understand each other. All right. So in that way, computers use protocols like TCP/IP, like one of the examples that you can see here. They call that the transmission control protocol. and the IP is Internet Protocol. So the computer uses these protocols to communicate over the network. So I hope this illustration is clear enough. Sometimes you have to just get the explanation using an illustratable explanation. So that is network protocol in simple terms. And an example is, I'm sure when you're browsing, you see HTTP, HTTPS. If you've worked in an environment where you do file transfer, so FTP, yeah, that's a file transfer protocol. Then you have the SSH, you have the SMTP, simple mail transfer protocol. This SMTP is used for sending email messages between servers. So this defines how the email clients and servers communicate to deliver messages to the recipients. The SSH is called the secure shell. All right. So this kind of provides some sort of encrypted communication between clients and servers. So it prevents what they call eavesdropping and authorized access. We have many more. We have POC3, that's a post office protocol version. We have IMAP, that's the internet message access protocol. So that protocol is used by email clients to access and manage emails that are stored on a remote server. So then we have the DNS. I'm sure we've all heard about the DNS, domain name system. So DHCP and all that. So those are protocols. I will move on to the next one. I want people to come back for the next class. So we have the network topology. I'm sure we've heard topology before if you are from where I come from, and I'm sure it's just around. Is it in mathematics or geography? We did something topology.
Geography.
Yeah, thank you very much. Yeah, so I can never forget this one. So it's the physical and logical arrangement of network devices, such as switches. We all know what network devices are. So I've kind of put everything like in layers so that we are getting the flow. So the network topology the arrangement of network devices, switches, routers, software. I don't know if anyone has worked in an organization where you have a server physically. If you work in a bank in Nigeria, where I'm from originally, and you have to work on the servers and press some button to do start of day, and all that. So there's a sort of arrangement and it's a standard, okay? So the logical arrangement of network devices, that is called the network topology. So it's like a map, a blueprint, the way roads connect various locations on the city. So network cables or wireless signals connect devices in the network, and the layout is a topology. The layout is a topology. So, and there are different types of network topology. We have the hybrid, we have the bus, we have the ring. I think the ring is easiest to remember, and the mesh. So you have a ring. When you have all those things coming inside the ring, it becomes a mesh topology, star topology, and tree topology. I'm going to send uh, the resources that I've used so that you can have some time to read more about them. Now let's have a look at the Amazing OSI model, the open system interconnection. I remember those days. If you're if you want to learn about computer, you get that textbook. I can't remember. You see this OSI model facing you. I'm sure when you see that image now, some of you are going to remember that you've seen that before. So the OSI model has 7 layers that the computer system use to communicate over a network. And I think from my research, it was introduced around 1983 and also adopted by ISO as an international standard in 1984. However, this OSI model is just used to understand how different parts of a network communicate with each other. I'm sure this looks familiar to some of us here. So it's a stack of layers, and each of the layer is responsible for specific tasks that are related to communication. So we have the physical layer, layer 1, which transmits the raw bit stream over physical medium. If you think of this like how do I put it now? So roads, let's say roads in a city. We have different roads leading to the city or coming out of city. So the actual transmission, um, and reception of raw data bits happens in the physical layer. So it provides the physical, that physical pathway. If you see, anytime you see physical layer, remember pathway. Like it provides a physical pathway for transmission of data. Okay. And data bits over this layer. So we have the data link layer, which is layer 2. This defines the format of data on the network. How do I explain this format? So it is similar to like a postal service. They ensure that your packages are correctly addressed, they are correctly sorted to the postcode that is going to, and they are correctly delivered to the right recipients. So the data link layer organizes the data into frames and ensures that they reach their intended destination within that local network. Then we have the network layer, which is layer 3. So this network layer, I think that one is like really close to home. It decides which physical path the data will take. So the network layer is like your sat nav, is your GPS system that is guiding the the delivery truck across the cities. So you go here, you go there. So it routes data packets because everything that happens on the network, the data communication, they go out in packets. So it routes the data packets through the various networks so that they can finally get to where to their destination. Okay. Then we have the transport layer. This it transmits data using transmission protocol. So TCP and UDP are also a type of protocol. Then we have let's just say this one is like a delivery service. A transport layer. So think of this layer as a delivery service that ensures that the packages are delivered intact and in the correct order. So we have the session layer. So this layer maintains connections and is responsible for controlling and ports and session. So okay, so let's say, for example, there's a conversation between two people over the phone. So is this layer that manages the forth and back, the ongoing communication session between the devices. So it establishes the connection, it maintains the connection, it works on terminating the connection. When you pick up the phone, somebody else is speaking over the other side. So that's what the session layer does. It maintains the connection. Then we have the presentation layer, which is a layer 6. This ensures that the data is in a usable format and is where the data encryption occurs. So the presentation layer is responsible for the formatting um, because it says it ensures that the data is in a usable format. It's responsible for the formatting formatting of the data, responsible for encrypting and compressing the data in a way that the application layer can understand, because this is the final layer. So this format needs to happen here for this application layer to have an understanding of how it's going to present it to the user. So the application layer, think of this as this like the software programs, your web browser, your email client, your video streaming apps. So application layer provides that interface. In fact, the interface I am looking at right now, you understand, is the application layer that has made that possible. All right. What you are looking at right now, the application layer is what makes that possible, because you are able, the interface is provided for users to access the network services. So what you can see, what I can see, you can think of everything that is happening behind in the other layers. So I would go into the next slide. And so the OSI model provides a structured way to understanding the complexities of the network. However, um, we now have, I think in recent times, the modern internet is not based on OSI, but on a simpler TCP/IP model. So these are protocols. It's on a simpler TCP/IP model. So the OSI model it hasn't gone into extinction. It's still widely used, okay, because it helps to visualize and communicate how the network operates, and helps to also isolate and troubleshoot networking problems. So you can see, you look at the OSI model, yeah, and the modern internet is based on the TCP/IP model. You can see that layer 1 and layer 2 fall within the network access layer of the TCP/IP model. Layer 3 falls within the internet layer. Layer 4 still falls within transport layer. So I was talking about transport a few seconds ago. So then we have the application layer, presentation layer, section layer, all the three falling into within the application layer of the TCP/IP model. And of course, we've talked about the network protocols. These are examples. I think there are a long list of like 12 protocols And if you go on that resource that I used, you're going to see a lot of them there. I mean, if you count all of this, yeah, I think there are 12. So that's just so this is what in a bit. I think these basics um are good enough for us to, we can go back and read in depth, more in depth, delve into anything that seems unclear. And I also would like that our group is, we are not just quiet there, we're just only waiting for when we're having trainings to do. Pop in your questions in there. And so that is me, question and answer. I think I finished right. I didn't spend 1 hour. All right, I'm going to stop recording now.